Hey guys, so today is April 8th, and I'm going to do another LeetCode Daily Challenge. Let's get started. So today's problem is minimum operations to make array values equal to k. It's another easy. We've been getting, yesterday was easy, and I guess today is another easy. But we'll see. I couldn't do yesterday's problem like super elegantly, so hopefully I could do better, but we'll see. You are given an integer array nums and an integer k. An integer h is called valid if all values in the array that are strictly greater than h are identical. For example, 10, 8, 10, 8, a valid integer is 9 because all nums of I are greater than 9. Or equal to 10, but 5 is not a valid integer. Strictly greater than h. You are allowed to perform the following operations on nums. Select an integer h that is valid for the current values in nums. For each index I where nums I is greater than h, set nums I to h. Return the minimum number of operations required to make every element in nums equal to k. If it is impossible, return a 1. Okay, I'm a little bit confused. So I'm just gonna run through what the example. I might have to read the problem again. Honestly, I have no clue what they're saying, but let's see. 52545. The operations can be performed in order using valid integers 4 and then 2. So we want to make every element in nums equal to 2. And how do we do that? Select an integer h that is valid. Something is valid if all values in the array are strictly greater than h are identical. That are strictly greater than h are identical. If all values that are strictly greater than h are identical. So okay. So 4 is valid because everything greater than 4 um are identical. Oh, because everything greater than 4 is 5 and all the 5s are identical. So there's no 6 or 7 that ruins it. Interesting. Okay, I think I understand what it means. So I'm wondering if we could have some like frequency counter that keeps track of how many appearances a number has. So 5 appears 3 times, right? Like here's our frequency chart. 5 will appear 3 times. 4 just appears once, and 2 just appears once. And then you want everything greater than the valid to be identical. So we could take the max, which is 5, and we could go 1 below it. So that means all of these 5s are gone, and now there will just be 4, or there will just be 1 plus whatever was in the 5. So there would be now 4 4s, and then we're done with this. So I'm just gonna put this in parentheses, like we're done with that. So now we this is our frequency. So we can go to 4. Um So that means we could take 4 away, right? And then just bring it to the 2. So it would be 1 plus 4 is equal to 5. So everything is, there's going to be 5 2's. And that's exactly what we wanted. 1, 2, 3, 4, 5, like that. Okay, let me, that kind of makes sense. Let's try example 2. So if our frequency is, so if our array is 2, 1, 2, 2 appears twice, 1 appears once. We'll take everything in 2. I guess it's impossible because 1 is smaller than 2. So there's no way that we could ever turn 1 into 2. So I think that's an observation. If the min of nums is less than k, we just return -1 right away. It could be a base case right here. And then I guess let me try one more time. With example 3, we have 9, 7, 5, 3. They're all appearing once. 9, 7, 5, 3. And our k is smaller than everything that we've seen so far. So that's fine. We take away the 9 and we just replace it with the 7. So now this is going to be 2. And then this is gone. And then now since we're ready to do 7, we can move down to the 5 and replace it. So it's plus 2 is 3. And then we could delete this one. And now we could do 1 plus 3 is 4. And then so we're just going to have 4 3's. And then we could delete this right over here. One operation, 2 operation, 3 operation. And the 4th operation is we will just take all of these 3's and turn them into the k, which is 1. So that's going to be the 4th operation. Okay. I think that makes sense. If min num is less than the k, return -1. Freak. I keep having this like counter, which can be tricky sometimes, but I think it should be okay. So it's default dict of int, where the key is like is the number and the value is like how many times they appear in the array. We could just do for value in nums, freak at value plus equals to 1. It would be good. It would be good if these are paired up. And what I mean by pairs is that if we had the number and its frequency like this, the value and its frequency, and we can do that by doing for vf in frequency.items, right? We could just look at all the items and just do pairs dot append v and f. And then I just wanted to sort it reverse true. So let me print pairs to start out just to make sure I'm doing this correctly. And then just for now, I'll just return -1. Five, 3, 4, 1, 2, 1. Yeah, that's exactly what I want, right? Like 9, 7, 5, 3. Okay. Yeah, that's perfect. Okay, what is next? Return the minimum number of operations required to make every element in nums equal to k. So I don't actually have to count, right? Like, we're just gonna move the biggest one into the next biggest one and keep going all the way. And our k is gonna be at the very bottom. So whatever is our size, we're definitely gonna use that many operations. So our operations is just the length. Maybe I don't even need pairs. It's the length of the frequency. And then the only thing we need to consider is if min nums is different than our k, then we just need to return operations +1. Otherwise, we just return operations, right? Let me run this and then I'll delete all the pair stuff because that was not helpful. So I'm outputting 5, but it really should be 4. If min nums, oh, should be like this, I think. Yeah, because at the last one, like if our k is 2, so we're going to change all of the 5s into 4s, that's one operation. Change all the 4s into 2s, that's the second operation, and then we're done. But then if our k wasn't the minimum, we have to change all the 9s to 7, change all the 7s to 5, all the 5s to 3s, and then all the 3s to 1. So we have to account for that operation, like an extra one. But I think we could just use length. So I actually don't need to pair them up at all. We just want all the unique. In that case, we don't even need to count a default dict, right? We just want all the unique numbers. And to do uniqueness, we could just keep track of a set. So I could actually just have S be a set of nums, which would just keep track of all the distinct values in nums. And our operation would just be the length of S. If the minimum of nums is not equal to k, return operations. Otherwise, return operations -1. That should work just fine. Yeah, interesting. Okay, I'm gonna go ahead and submit that. Cool. Yeah. Oh, 100 days. That's awesome. Kind of sloppy just because I went down kind of a rabbit hole of unnecessary work, right? Like the solution didn't even need to keep track of the count. And I mean, this can be simplified even more. But anyways, that's fine. So if all of nums is unique, okay, sorry. So for space and the time complexity, just linear time, and then linear space as well. And yeah, that's it. Yeah, cool problem. Not that bad. I spent probably too long to get the solution, but it's cool. See you guys tomorrow. Thanks for watching.